Hey guys, I want to take some time to go over series and parallel circuits just in case you missed it. Alright, so clearly they're different. A series circuit looks like this and a parallel circuit looks like this. Now the first thing that I'm going to talk about is a series circuit. The main difference with a series circuit is that there is one path for current to flow. So there's only one way it can go. There's no options. So we have a battery and we have resistors. So the battery has a positive end, which is denoted by the longer line, and it has a negative end denoted by a shorter line. All right, so it's big, long line, short line, long line, short line. All right, and that's going to matter for the next topic we talk about. Then we have resistors. And then these straight lines are just wires that would connect those resistors. All right, so looking at this circuit, this series circuit, there's only one way for the current to go. It can go this way, and it's only going to flow like this. It's one path of flow. And there are a few things that are true about series circuits. The first thing that you should know about a circuit is that we have something called the equivalent resistance, which is Req. This is like the total resistance. So I can simplify this circuit right here into a smaller circuit that has one resistor. So I can combine all three of these resistors and it'll just be one resistor. And that's going to be called the equivalent resistance. So this can go to something that has one resistor. For a series circuit, if I want to find the value of this one resistor, which is called the equivalent resistance, I can just add up the ones I combined. So R1 plus R2 plus R3, which I have written right here. If you have 50 resistors, it will be R1 plus R2 plus R3 plus R4 plus R5 plus R6, and so on until you get to Rn or R50. Now, what's super nice about series circuits is that the current all throughout this circuit is the same. Since the current flowing through this resistor is the same exact current flowing through those two resistors, it's going to be the same. So the way I would find that current is by finding my equivalent resistance, and then if V is equal to IR, then I will be equal to V over R. So the voltage of that battery divided by the equivalent resistance, and that's going to give me the total current, which will be the same all throughout. So they all have the same current. The equivalent resistance is the resistor values added up. And then the voltage, the total voltage of this circuit is going to be the battery voltage. So whatever this battery voltage is, so if it's 12 volts, the total voltage is 12. Now, with that being said, the voltage, that 12 volts is split up between these three different resistors. So the voltages of those resistors have to add up to give you 12, which I have right here. The total voltage is the sum of the individual voltages. And if I want to find those individual voltages, after I calculate the current going through, I can use V is equal to IR. So V1 will be I1 times R1. V2 will be I2 times R2. And V3 will be I3 times R3. So if you're ever given a series circuit, you're going to get a paper like this where you have to solve for the current through each resistor and the voltage through each resistor and the power of each resistor. So in order to find all those things, I have listed some steps for you guys. So the first step will be to find the equivalent resistance. The next, and you find that by adding up the resistor values. Then find the total current by using I is equal to the total voltage over the equivalent resistance. And then we know that the currents are going to be equal, so let's just plug that into our chart. And then 4 is find all the voltages using Ohm's law. And then 5 is find the power using P is equal to IV. Now, if you add more resistors or light bulbs in a series circuit, remember, since the voltage is split, if you add another resistor add another light bulb, it's going to be split even more. So the brightness is going to go down. And another thing is, if one of the light bulbs go out or one of the resistors is broken, this whole circuit will be broken. All the light bulbs will go out. So that's true about a series circuit. So with that being said, let me take some time to solve a series circuit question. All right. So we did this one in class. So we have to find the equivalent resistance, total current, and the voltage and current for all of the resistors. So the first step is going to be to find my REQ. So when I find my REQ, I want to redraw my circuit. And then it's going to have one resistor. So 15 volts is my battery. And then REQ will be 10 plus 15 plus 25 plus 20. And let me just use my calculator to show you guys. So 10 plus 15 plus 20 plus 25. So 70 will be my total resistance. So 70 ohms. Let me add that in my chart. Now, if my total resistance is 70 and my voltage is 15, I can do step 2 and find my total current, which is V total over REQ, which will be 15 divided by 70. Which is 0.214. So that's my total current. But since this is a series circuit, they're all the same value for current, which is really nice. Now I have to find my voltage for each one. So if I know my resistance and I know my current at all these points, I can find my voltage. So V1 is I1 times R1. V2 is I2 times R2. V3 is I3 times R3. And V4 is I4 times R4. What's super nice is the currents are the same. So it's going to be 0.214 times 10, 0.214 times 15, 0.214 times 20, 0.214 times 25. All right. .214 volts. Add that in. 0.214 times 15 is 3.21. 0.214 times 20 and then 0.214 times 25. Now, to find the power, and before I move on, if my total voltage is 15, like I said, all these have to add up to give you 15. So let's just check that. So it's going to be 2.14 plus 3.21 plus 4.28 plus 5.35. 14.98, which is really close to 15. The reason it's not exactly 15 is because I rounded. So remember the current was 0.214 with some other decimal places. All right, so now the power. P1 is equal to I1 times V1. So it's going to be 0.214 times V1, 2.14, which is 0.458. Then for P2, it's I2, which is 0.214 times V2, which is 3.21. 0.687. 0.214 times 4.28 gives me 0.916 for P3, and then 0.214 times 5.35 gives me 1.14 watts. And then if I want my total, P total is going to be equal to I total times V total, which is 0.214 times 15, which was my total battery voltage. 0.214 times 15. 3.21. So if that's my total power, all these powers should add up to give me 3.21. So that's how I solve a series circuit. Now, parallel circuits, which are the more spicy circuits. So for parallel circuits, they look like there are multiple paths of current flow. So if I have current flowing through this battery, once it gets to this point, some of it can go down here and some of it can go this way. So there's not one path. Over here, there was just one way for it to go. Over here, once it gets to a certain point, it can split multiple paths, all right? So that's the main difference, but be careful. You know, it's called a parallel circuit because these resistors look parallel to each other, but all a parallel circuit is it's multiple paths. So a parallel circuit could also look like this. So this is parallel because we have multiple paths. Even though this resistor right here isn't necessarily parallel, since this current split, it's a parallel circuit. An easy way to tell if a circuit's parallel is seeing if it has T-spots. So like a T. All right? Now, the first thing I want to talk about is the equivalent resistance. So over here, to find the equivalent resistance, we just did R1 plus R2 plus R3. We cannot do that with this configuration. For the equivalent resistance of a parallel circuit, it's 1 over the equivalent resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus ... all the way up to 1 over Rn. Now, if this is 10, this is 15, this is 20. Please don't do 1/10 plus 1/20th plus 1/30th. Oh, that's 1/60th, because that's not how you add fractions. So I would say put this in your calculator. And then when you put this in your calculator, you're going to get a number over here. Once you do 1 over R1 plus 1 over R2 plus 1 over R3, you're going to get an answer. Then take 1 over that answer, because this is not REQ equals this. It says 1 over REQ equals that. So if I were to solve this algebraically, this is what I would actually get. 1 over R1 plus 1 over R2 plus 1 over R3. So I say all that to say that's how we find the equivalent resistance. Now, what is special about a parallel circuit is while a series circuit has the same current, a parallel circuit has the same voltage. So let me just write that. Same current. And then parallel circuits have the same voltage. Now, so whatever my voltage of my battery is, that's going to be V1, V2, V3, all the way up to however many resistors we have. Now, the current for a parallel circuit adds up. So the current at R1, the current at R2, and the current at R3 must add up to give you the total current, which we find after we find the equivalent resistance. So the steps for solving the parallel circuit are a little bit different. First thing we can do is, if we know the total voltage, let's just add our voltages in. And then we can find all of our currents using I is equal to V over R. Because now I know R1 and V1. I know R2 and V2. I know R3 and V3. The only thing I don't know is I1, I2, and I3. So after I find all the currents, I can find the power. After I do all that, then I can find the equivalent resistance and the total current. All right, so and what's interesting about a parallel circuit is if you add more light bulbs, the voltage is going to stay the same. If I were to add another branch, the voltage is the same, so the light bulb is just going to be just as bright as the other ones. It's going to stay the same because the voltage is the same. And another special thing is when you add, when one of the light bulbs go out, it doesn't affect the other ones because it has its own path. That path doesn't affect the path of other elements or resistors or light bulbs. All right? So let's just jump into a problem. Now, I have a parallel circuit because I have multiple branches. The first thing I want to add in is, boom, my battery is 15 volts. So 15 volts, 15 volts, 15 volts, and 15 volts. So let me just write my voltage for all of them to be 15. All right. Now that I know my voltage is 15 and I know my resistances, I can go ahead and find all of my currents. So V1, oh sorry, if V is equal to IR, I1 is equal to V1 over R1, which will be 15 over 10. I2 is equal to V2 over R2, 15 over 15. I3 is equal to V3 over R3, which is 15 over 20. And then I4 is equal to V4 over R4, which is 25, or sorry, which is 15 over 25. All right, so 15 over 10 is going to give me 1.5 volts. This is going to give me, 1.5 amps. This is going to give me 1 amp. This is going to give me 0.75 amps. And this is going to give me 0.6 amps. So let me write all that in my chart. 1.5, 1, 0.75, 0.6. Now, flipping to the front, look, same voltage, different current. Now, for a series circuit, it had the same current, different voltages. So they're kind of like the opposite. Now, I know my V's, I know my I's. I can go ahead and calculate my P's now. So P1 is equal to I1 times V1. So I1 is 1.5 times V1, which is 15. 22.5. Then it's going to be 1 times 15, which is 15 watts. Then it's going to be 0.75 times 15, which is 11.25. And then P4 is 0.60 times 15, which is 9 watts. And all I did was the I's times the V's to find the P's. All right, now P total is going to be I total times V total. I don't know what I total is, so I have to find it. But before I do that, I have to find the equivalent resistance. All right, so now find REQ and IT. So let me redraw this with one resistor. This is 15 volts. This is going to be REQ. Let me take some time to find REQ. So 1 over REQ equals 1/10 plus 1/15 plus 1/20 plus 1/25. So 1 over REQ is equal to 1/10 plus 1/15 plus 1/20th plus 1/20th.257. This is not REQ. This is 1 over REQ. So if I want to find REQ, I can just do 1 over 0.257. And the reason for that is if I cross multiply, I get 1 is equal to 0.257 REQ. So REQ will be equal to 1 over 0.257. Oops, 1 over that. It gives me 3.90 if I round. So my equivalent resistance is 1 over 0.257, which is 3.90. And then my total current is V over REQ, which is 15 divided by 3.90. Which is 3.85. I also could have known that if I would have added all those up. So 1.5 plus 1 plus 0.75 plus 0.6. Boom, 3.85. Final thing is total power, which is my total current, 3.85 times 15. 57.75 watts. All right. So also what I want you to notice is that my REQ for a parallel circuit was smaller than all my individual resistances. 3.90 is smaller than 10, smaller than 15, smaller than 20, smaller than 25. So for a parallel circuit, the REQ is always smaller. Versus for a series circuit, the equivalent resistance, which is 70, is bigger than all those numbers. So I hope this helped you with series and parallel circuits. If you still need some help, ask me questions in class. You guys should do pretty fine on this beginning topic.